right, so if you're watching this video, you're either in my class or you have some questionable viewing habits on YouTube. Like, who watches math videos? Seriously. This is 13.5 for me, which is the basic sinusoidal graphs. It's going to be the graphs of sine and cosine. That's as far as I'm going to take my Algebra 2 kids with trig graphs this year. The vocab coming up is the period. Period is how long it takes for the graph, in this case, of sine or cosine to repeat. And unless a transformation has occurred, the period of sine or cosine is going to be 2 pi, or 360 degrees. But, we don't really graph with degrees because we'd have to carry the grid out so far. But, we could. We could. Midline is going to be a horizontal line right down the middle. It kind of separates your peaks and your valleys. It's also known as the vertical shift. It's K, and you have amplitude as distance between the midline and a max or a min. One of the two. All right, first up is the graph of sine of x, and we're going to do a cycle to the left and a cycle to the right. These are some old notes, probably from 2016, so I'm not sure what's in that box. It probably talks about unwinding the circle. Helps to remember that sine starts at the origin. From there it rises till it can rise no more and begins falling till it can fall no more. So remember psi y. All right, remember psi y. Now, the way we handle the x-axis is we actually talk about the angle. Okay, so this would be 0 pi, and I use what's called a 5-point technique, which most people do. And a full cycle would go out to 2 pi. Halfway between 0 and 2 pi is pi. Halfway between 0 and pi is pi over 2. And halfway between pi and 2 pi is 3 pi over 2. And we just use symmetry and, recopy this for the negative angles. Now, if we look at the sine of 0 pi, we have a y value of 0. If we look at the sine of pi over 2, we have a y value of 1. At pi, y is back to 0. At 3 pi over 2, we have fallen to negative 1. And at twice pi, we have risen back to the midline, or to the x-axis. So one full cycle of the sine graph to the right looks something like this. And you're just unwinding the circles all you're doing. Working backwards, negative pi over 2 would be right here. It would be negative 1. Negative pi would be right here at 0. Negative 3 pi over 2 would be back up to 1. And then negative 2 pi would be back to a y value of 0. So here's the one cycle to the left. And there is 2 full cycles of the graph of y equals sine of x. Now the equation of the midline here, the midline is the horizontal line that goes right down the middle. And I get appalled every year by the number of kids who can't tell you what the equation of this is. I just don't know what you've been doing in high school. But that's a horizontal line, so it's y equals, and anywhere on that imaginary line, y is 0. I should probably be calling it imaginary. It's just a line that's not really there. It's understood to be there, but it's not there. The default amplitude, the distance from the midline to a peak or to a valley, is 1. Amplitude starts with an A, by the way, so A is 1. And the period is how long it takes to complete one full cycle. So the period is going to be twice pi. All right, that was sine. Here comes cosine. And cosine is going to be very, very similar, except instead of looking at y values, we're going to be looking at x values. And cosine does start high, and there it has to fall. We're going to key out using the same 5-point technique. 0 pi to twice pi. Half of twice pi is pi. Half of 0 and pi, or smack dab in the middle, pi over 2, and then 3 pi over 2. Period's going to be 2 pi. Amplitude's going to be 1. Equation of the midline is still going to be y equals 0, because this is a mom function. But anyways, you'll see it in just a minute. So if we look at 0 pi, we have an x value of 1. If we look at pi over 2, we have an x value of 0. If we look at pi, we have an x value of -1. And then we're back back to 0, and we rise back to 1. And that is one cycle to the right of the origin of cosine. And mine went a little higher than it was supposed to. Now, it's going to do the same thing on the left. There we go. There's two full cycles of cosine. And the graphs are really, really similar. They only differ by pi over 2. Wish I had a good way of overlaying them on top of each other. They're not hard to do. They're really not. And, you know, I realize that it's the end of the year for my kids. It's May, you're done. Like, look at that. Like, I need you to understand how important that is to the world you live in. That is communications. That is electricity. That is EKGs and stuff like that. It's all about these trig functions. Trig is just, man, it's a big deal in your world. All right, graphing equations in the form of y equals a times sine of bx plus k, or y equals a times cosine of bx plus k. Man, an example here is y equals negative 3 sines of 6x, and let's say plus 5. Now, what does this do? Well, it does a lot of things. Okay, your amplitude is now 3, because this is the letter A, okay? K is 5, so it has been shifted up 5. There's a negative out front, which is a reflection over the x-axis. So instead of sine rising in this example, sine would fall. And a big thing here is this, okay? This bx. Now, the period of sine or cosine is 2 pi. Doesn't matter which one it is, it's twice pi. When a b value is present, now you may or may not remember this, but this is the horizontal shift or compression. That's what b does. It's a horizontal stretch / compression. I said something else because I ain't 100% today. But it's a horizontal stretch or compression. So when a b value is present, your period changes. Your period is 2 pi over, I'm going to use uppercase b. And the key points are simply found by dividing the x-coordinates by b. So, you know, like I had, if I just do a graph here, my key points are 0 pi to 2 pi. With a b equal to 6, it changes. The key points change. You know, this becomes 2 pi over 6, which is pi over 3. Now it goes out to pi over 3. This is still going to be 0 pi. Pi divided by 6 is pi over 6. 3 pi over 2 becomes 3 pi over 12, which is pi over 4. And pi over 2 becomes pi over 12. You can just take your key points and divide them by b, and now you have new key points. So they're really not that hard to work with. Of course, it's the fractions, which is going to bug you. Identify the amplitude, midline, and period of the graph below, and then write its equation. All right, so let's start with amplitude. How tall is this thing? It's 1, 2, 3, 4, 5 units tall, so A is 5. And that is A, by the way. A is for amplitude. The midline on this one is right down the middle. It's y equals 0. We should have plus k. That's a b. I used to use the Greek letter omega. I don't do it anymore. Now the period is something that kids are going to struggle with. A period is how long it takes for one complete cycle. That means when we start repeating y values, the period on this one is pi. Okay? The period is pi. Does all its business in pi units. Let's write their equation. This looks like sine. it looks like sine, doesn't it? That was cosine, this is sine, sine starts at the origin. So it looks like sine. So it's y equals, the amplitude was 5 sines. K is plus 0, so it doesn't really matter. I got to figure out what goes in here. So on the previous slide, I said the period is 2 pi over b. And I know the period is pi, so pi is 2 pi over b. Well, what does b have to be? The 2's have to cancel, right? So b is 2. Twice x is inside. And this is my equation for that graph. Easy peasy lemon squeezy. Graph y equals -4 sines of 4x minus 2. The amplitude on this one is 4. This is b. The b is 4, which means that the period is 2 pi over 4, which is just pi over 2. Is it reflected? Yes. So normally what sine does is sine does this. It has been reflected. So it's going to start low and go high because of the reflection. That's a really bad graph. But anywho, I need to go down 4 and I need to go up 4. Tick marks aren't the best spot, but whatever. I'm still going to start at 0 pi, but I'm going to go all out to pi over 2 this time. Now halfway between 0 pi and pi over 2 is pi over 4. Halfway between 0 pi and pi over 4 is pi over 8. Halfway between pi over 4 and pi over 2, a little harder to do, right? Isn't it? I feel like it is. Should be 3 pi over 8. And I know you're like, man, Milbrath, that's a fraction. I can't do that. So let's think about this. We do 1/4 plus 1/2, and we're finding an average because we're finding the middle, and we divide by 2. This becomes 1/4 plus 2/4. Remember? 2 times 2. So 1/4 plus 2/4 is 3/4, and 3/4 over 2 is 3/8 because we just moved the 2 up by 4 and we multiply. Now, since it's been reflected, it will not start rising, it will start falling. It will start at the origin, and then it will fall 4, it will rise 4, it will rise 4 again, and once it gets as high as it can get, all it can do is fall back down to earth. And there is the graph of my equation. Almost. The midline is y equals -2, and this is also the vertical shift down 2. I didn't even catch that. I didn't even see that thing. I was somewhere else. So it's going to be a little bit different. Let me put some dashes on this one because it's not really there. So y equals -2 is a horizontal line that goes right there. Now I'm going to need to fall 2 more units. It shifts the whole graph down 2. We'll start here, and from there we'll fall 4. And from there we'll rise. And from there we'll rise again. We'll rise up to that 2, and then we'll fall again onto the midline. And then we will unwind the unit circle. So my solid red graph is the final transformation. And some kids see that and some kids don't. Some kids think the dashed one is the graph. Whatever. Pay attention in high school. All right, graph 3 cosines of 1/3 x plus 2. I keep calling this omega in the notes. I changed it over to b. I just didn't edit the notes all the way. All right, your amplitude is going to be 3. And by the way, this is cosine, and cosine starts high. That's what cosine does. You just have to know what mama looks like. She has been shifted up 2, and she's going to rise 3 points. So I need to actually go all the way to 5. 1, 2, 3. Because this is the midline. And unlike the last one, I'm not going to draw the wrong thing on this one. That's positive. It hasn't been reflected. The period is going to be 2 pi over 1/3, which is 6 pi. Now, the reason I have so many points on here is because I'm going to do 2 full cycles. That's the only reason I have so many points. but the period is 6 pi. So I use a 5-point technique, start at 0 pi, 1, 2, 3, 4, 5. Sorry, including that one. And we're going to go out to 6 pi. Halfway between 0 pi and 6 pi is 3 pi. Halfway between 0 pi and 3 pi over 2, 3 pi is 3 pi over 2. And 3 plus 6 is 9, cut in half, 9 pi over 2. All right. Now I said I was going to do another cycle, so I'm going to add another 6 pi. That'll take me to 12 pi. Halfway between 6 pi and 12 pi is 9 pi. Halfway between 6 pi and 9 pi is 15 pi over 2 because we add and divide. Halfway between 9 pi and 12 pi is 21 pi over 2. And let's go ahead and start graphing these things. So this is cosine, and cosine starts high. It has an amplitude of 3. It's going to start 3 units above the midline, and then it's going to fall to the midline, and then it's going to fall 3 units more, and then it's going to rise 3 units, and then it's going to rise 3 units again, and once it gets as high as it can possibly get, it falls, and it keeps falling until it gets as low as it can possibly get, and then it rises, and it rises until it can get as high as it can possibly get. So like I said, these are not so bad. They're actually quite simple, but you know, I got numerous kids who can't graph y equals mx plus b, so I don't know how you're going to graph this. And hey, that's it. That's it. So there is the equations of the sinusoidal graphs. You're welcome.